Welcome to today's physics lesson. I'm Michael Mutembe and we are going to learn on how to solve problems related to Newton's laws of motion. Now, our first equation reads that state Newton's second law of linear motion. So, the Newton's second law of linear motion states that the rate of change in linear momentum is directly proportional to the resultant force producing the change and takes place in the direction of the force. So, we are going to apply this law in solving our question. The legal speed limit on motorways is approximately 30 meters per second. In an incident on a motorway, a car of mass 900 kgs leaves a skid mark 75 meters long. When stopping, the maximum deceleration of the car when skidding is approximately 10 meters per square second. Roman 1 question says, show that before the incident, the car must have been traveling above the legal speed limit. So our question is asking us that we show that the initial speed of the car before the incident was above 30 meters per second. Now, we are going to apply the equations of linear motion. So our first equation is V is equal to U plus AT. And then the second equation is we have S is equal to UT plus half AT squared. And the third equation is V squared is equal to U squared plus 2AS. So, for this equation, we are going to apply one of the equations in solving the problem. In our question, we have the maximum speed limit, we have the mass of the car, and we have the displacement and the deceleration. So, in solving the question Roman 1, we are going to use the displacement and the deceleration. And in our first equation, there is no displacement. So, we are not going to apply the first equation. For the second equation, we have the displacement, but we don't have the initial velocity, we don't have the time, and we have the acceleration. So this equation we are not going to apply because we do not have the initial velocity as well as the time. So for the third equation, we have V squared, which is the final velocity. V is the initial velocity, what we are searching for, and U is the final velocity of which we know it's 0. The acceleration, we have it as 10 and the displacement as 75. So the third equation can apply in our concept. So we are going to say V squared is equal to 0 squared plus 2 times displacement 10 times 75. U squared is 0. 0 squared is 0. So we have the value of V squared is 1500. We are going to find the square root in both sides. and our value of V will be 38.72 meters 0.72 meters per second. So this is our first equation. For the second equation, we are told to calculate for this scheme the maximum average braking force between each of the 4 tires. So according to Newton's second law of motion, we know F is equal to ma, and we are finding the braking force. We have the mass of the car and the deceleration. So F is equal to mass, which is 900, times the acceleration, which is 10. So we will have F is equal to 9,000. When we have F as 9,000, we are told for each of the 4 tires. So this is the braking force of all of the 4 tires. But we want to know the braking force of each tire. So we are going to say 9,000 divided by 4 tires, because the tires of the car are 4. So 9,000 divided by 4, we are going to get the final answer as 22,250 joules. The last question reads, when the motorway is wet, the braking force provided by each wheel is reduced to 50% of the calculated in Roman 2. So the braking force will reduce by 50%, that is which we have calculated in Roman 2 as 2250 joules. And now we are told, what is the effect of this reduced braking force on stopping distance? Explain your answer. Assume that the speed of the car before braking is the same in both cases. So we are told the effect of this reduced braking force after the braking force reduces by 50%. What will be the effect of that on the stopping distance? Already the stopping distance initially was 75 meters, and this stopping distance will be affected by the decrease in the braking force. So we are going to say the motorway is already wet. We know that the wet surfaces offer little friction compared to the dry surfaces. So our answer will be wet surfaces offer little friction compared to the dry surfaces. Resulting to increase in the stopping distance. I have been your presenter, Michael Mutembei. For more related concepts on physics, keep tuned to Education Channel 1.